Hi everyone. In this video, we'll talk about how to connect an AI SDK agent to an MCP server. In the last videos, we saw how to use an AI assistant like Cloud Desktop to connect to an MCP server. In this video, we will specifically learn about like AI SDK agent. For example, OpenAI SDK agent. So basically, this AI SDK are the programmatical way by which we can build an agent. So we will learn how to build such framework, now how to use such framework to connect to an MCP server. And we'll start with the STDIO protocol. So the advantage of this using SDK agent is like they provide full flexibility, to build in complex AI agentic system workflow. In case of cloud desktop kind of thing, you are limited by that cloud desktop, like whatever facilities are there, you can do with that, and you are dependent on them. But now using an SDK agent provides you full flexibility to build your own complex, any way you want an MCP, sorry, not an agentic system. Okay, so that's the main advantage of using an SDK agent, and that's what we must learn how to connect this agentic system to an MCP. Okay, so yeah, so let's start. So in the last videos, we saw like just to give an overview, like so your client tries to connect to an MCP server using either STDIO or HTTP protocol, and in the STDIO is like standard input and output where client and server communicate, whereas the HTTP protocol is where the server is hosted on some URL, and the client send a request via HTTP post request and get a response from the server as a response body. Okay, and when we talk about agent, we can have an SDK agent like OpenAI SDK agent, for example, where programmatically you build an agent, whereas the alternate was the assistant what we saw in previous video, the cloud desktop kind of thing. So in this video, we'll focus mainly on the using OpenAI SDK agentic framework, and particularly the STDIO. So the next video we will switch to the same thing on the HTTP one. Okay, so now so we'll be using the same time and file system MCP server what we saw in cloud desktop. And now how to connect our agent building, using this OpenAI SDK and connect to this server. As I said, there are two protocol, and in this OpenAI SDK agent framework, there are two Python modules we need to use. So for STDIO, the module is MCP server STDIO, whereas for HTTP mode, we have to use this package. Okay. So yeah, so what we need, like we need to import that library what we need, and we need to have an OpenAI account, and we need to set up our OpenAI key and the environmental setup, and we just need how to configure the time and file MCP server. So we'll see that. So in my GitHub repository, if you go to this MCP with OpenAI SDK, you will see the code STDIO mode, right? So that you can open, and you can start working on it. Okay, but we need some setup, as I said. For that, already there was a video I created for setup, but just I will quickly tell you like what all things we need. We need to have an installed UB, and create a virtual environment and activate it, and install all the dependencies that Python packages we need. So for this, basically we need python.env, OpenAI agents for creating agents, and we need a Gradio for creating a chat interface. Parallelly, we need to go to this OpenAI framework, OpenAI platform, and there you can go to API key and create your own API key. And you get that API key and store it in a environmental variable .env in this repository, and you can store like OpenAI key equal to your key. So that way, when we do load the environment variable from this .env file, your OpenAI key will be set up. So with that basic minimal instruction, we can start. But yeah, I think forgot to one thing. So now we need can also use local MCP server. Okay, for that we need to download the Olama. Okay, Olama already. So if you go to olama.com, so you can download this Olama for installation. So you can go to this. I think here you can download this. Uh, I don't know where it is the download. Yeah. So when you download this, it will be downloaded, and it will you can pull the few local LLM model. I have created separate videos dedicatedly for how to configure your agent to use local LLM model, because which is free, right? So you can connect, so that for that I will also provide the description in the video. You can watch it. But yeah, so in short, let's assume that you could do all the setup, and let's jump to the hands-on. Okay, so let me just minimize this. So yes, we will be connecting our OpenAI SDK agent to both time and file MCP server. Okay. So first thing first, we need all these libraries. So let's load all this. We need .env. We need this agent library. And for local LLM model, we need this to use from OpenAI, async OpenAI model, and from agents we need to import this OpenAI chat completion model. So just basic in Python import libraries. So we import it, and here we load the environment. So basically what it will do, it will load my OpenAI key into this environment. Okay. So now before building an agent, one thing that you can do is just check the MCP server. Okay. So now, as I said, let's go to the time MCP server. So let's go to the time MCP server, and here you can see the instruction that so it has two tools, get current time and convert time. So the instructions says like how to use UVX. The command is UVX, and what argument you have to give, MCP server time. So basically we can just copy this JSON block and just create, assign it to a variable. So for example, here I'm just telling the fetch parameters equal to, this is what the command is UVX, and argument is this one. So now this is just the one line of code by which we define the MCP server. So here what we are saying, that async with MCP server STDIO, because we are using STDIO protocol, and here we are giving what command I want to use to connect to that MCP server. The command is over here, that fetch parameter. And then you say additional parameter like how much timeout you need, because this may timeout, because if it is take some time to host that MCP server, it may timeout. So you can just say like how much time you can wait. So and then what you are doing here, this block, you are with this one, you are just assigning into some variable name. This is the server name, so you can write any name here. So you can say like this is time underscore server, but I'm just giving server here. So now this is the object we will be using throughout the downstream. So this server is now, MCP server is now stored in a variable called server. Okay, and again this is all this work in asynchronous mode, so that's why you have to append async before calling anything. Okay, so now with that server initialized here, so now we can just call the server like, hey, what are the different tools you have, can you please give me? So this list underscore tools command will fetch all the tools that are listed in this MCP server. And again, since this is a asynchronous call, we have to use this await command. So now let's run this. So basically what it will do when I run this, so this will basically download from the GitHub repository this MCP server time locally, and then using this command UVX MCP server time, it will run the server. Okay, and again it will run in which mode? STDI mode. That means now this server is able to listen to the client using standard input and output stream. Okay, so here we have not created any agent here, but here we have just showed like what are the different tools available. Okay, so now you can see we have get current time and convert time. These are the two tools available over here. Okay, so with that, let's start our first agent. Okay, so we can define an LLM model, GPT 4.1 Nano. This is an OpenAI model, but for that it's a paid model. I've already adjusted my quota, so I will be alternately just show you how to use a local Olama model. Okay, so I have installed my Olama, and this model is available. Okay, and then with this 3 line of just code, I can now use this local Olama model. So what I'm doing, I'm creating a client here. So my Olama is running in this port or localhost 11434. Using this API point, I'm creating a client saying that, okay, so my this is the client and this is the model, and here I'm using that client what I created, right? So and then I'm giving this model, I'm creating an LLM model. So now these are the 3 boilerplate code, basically just copy paste and you change the name over here, and rest everything will work. So basically here we have created a local LLM model. So this is the name of the model, is the variable name in model. So now here I'm giving an instruction to an agent. Hey, you are a helpful assistant that can be that you can use tools to answer the questions. Okay, so here this is the main code, basically the same line of code. So here you are seeing that async with stdio, giving the parameters. The parameter is nothing but UV, the command, actually the configuration what you use, and then 60-second timeout, and the server is the object. So this line here, you are creating an actual agent. So here you see you're giving a name, you're giving the instruction, you're giving the model, which is the local Olama model I'm using. As I said, alternately you can use the paid model from OpenAI. And here this is the main core part. This is where you are telling that, hey, hello agent, you are now associated with this server. Okay, so this is the line that you can connect to the server. Okay, so now this is how you define an agent here. But one thing, just you see that all this thing, whatever we are doing, you're defining an agent or interacting, everything should happen within this inside this server block. Okay, so that's why you can see a right indentation. This is within this block. Okay, so once my agent is defined, I will just interact with simple query. Hey, what is the current time in, let's say, Chennai in India? And this is my query. And now in OpenAI SDK framework, you can call an agent very simply runner dot run, and you give the agent here and what query you are asking, and now it will run and it will give me the result dot output. So let's run this. So basically what will happen now, this agent will take this query, okay, and print an output to the standard output. So that will go to this server, that will take as an input from STDIN. Now it will understand the query. Now it will check which tools to call. The agent will now first call that MCP server list of tools. It will get that, hey, okay, this has 2 tools, so why not call this get current time tool? Okay, because I have asked, I have not asked the conversion, right? I have asked this one, so it will call that tool, and then it will give me the answer. Okay, so I something it get an error, then it's finally the time it says like 47 AM. Okay, so you can now, we can go and check the traces. Okay, so if I go to my OpenAI framework, and if I go to logs, platform OpenAI, so let's go to traces over here. Okay, so here I think this is the one. Let's go. It has called one tool. So initially, you see it first called the list MCP tools. So basically, it called the MCP server and asked like what are the tools available. So you will see that there are 2 tools we got. Now this is the generation. So this is the system prompt. I ask like, you are a helpful assistant, what you can do. This is the query user asked like, what is the current time in Chennai? Okay, so now what the agent did, like it called this get time, and then it gave me an output. And now it called that function get current time, and it got some, it called some error. I think no, it did not get any error. So it called in this format, right? Get current time, and time zone is Asia Kolkata, and then it got some output. And then I don't know why it called again, but finally it gave the final output. Something. I think it tried second time. I don't know what happened here, but I can't see the second time called here. But it gave the correct timing in final output. So yeah. So this is how it works. Okay, so basically in short what we did, like 2 lines of code, define the server, and within that define an agent, define the query, and this line of code you are calling that agent. Okay, so now, so this is one way to interact. Okay, the alternate is like we can create a chatbot as well. Okay, so this already we have talked in previous video series, but you can watch more other videos, like how to create chatbot. But here I'm defining a memory, which is the escalate session. So in which I'm defining a chat function here. So very simple, same line of code what I wrote here, right? So I take this one and I just put it over here. So you see async, same as server, and here defining an agent, there is no change. So instead of runner.run here, instead of query, we will use this MCP, this message variable, and we get the results, and we are returning the output. So basically I have defined a chat function, which I will put that above code into a very simple function, chat function. And again, this is a asynchronous function, so I have to write async here. And I will be using this Gradio, interface. So Gradio package to, create a very simple chat interface. So here you say gr.chat interface, pass the chat function and title and give some name. So when you run it, right, it will take some time to launch locally. Basically what it is doing now, it is now again doing the same thing in a chat interface. So let me pause for a minute and I'll be back once it is run. Oh, it already run started, so no need to pause. So I'll just open this one, copy this one here. Otherwise I can click it here. Okay. So now you see it can easily open in a chat window. Okay. So now I can ask, what is time in Mumbai now? Okay. So now it will take some time. It will now, since I'm using my local model, right, it might take some time to respond. Okay. But what behind the scene it is doing is, yeah, it is fetching that, this one, and it is executing. So let's wait for some time, whether we get some response or not. Okay, we got a response. The current time in Mumbai is this one. So you can also ask like 5 p.m. in India is what time in London. Okay, so let's ask this one question. So now it will go and ask this. So we can also go to traces and check. Okay, so if you go back to traces, my previous one, what happened? The same call happened, like get current time. It called and it gave the response, the time. Okay, the current time in Mumbai is this one. But now let's check the latest traces. So it called what tool? So you see now this time it called. It first called the list tools, then it calls what convert time tool. So it called the tool. So see automatically it defined the input to call, and then finally it gave me a response that the current 5 p.m. is equal to 11:30 a.m. in London, which is a difference of this many minutes. So this is, see how beautifully we have you know 2 lines of code. Basically we have created MCP server. But one advantage of is this is what I like to highlight is like, so for example, if you see here, right, hover over this MCP server STDIO, you will see that some other parameters that you can use. One's called cache tool list, means because every time it is calling the list of tools, right? Let's say you have an MCP server that is 100 tools. So every time you will call, it will give you 100 tools, and let's say each tool, let's say defines, consumes 50 tokens. Okay, because it has some instructions right in the tool. So you can imagine each tool 50 tokens, and 100 tools means you are almost consuming 5,000 tokens. That means you are unnecessarily paying that much money. So to save that, you can you can enable this one cache tool list. So basically it will locally cache those tools, so the next time it will not call again. Also, there is something called tool filters are there. We can further filter tools like, hey, out of 100 tools, let's say you can, using some regular expression, you can filter like anything that starts with get, only those fetches. So out of 100 tools, now you will get only 5 tools. So that means you will consume 5 into 50 tokens, only 250 tokens, not to 5,000 tokens like all the tools. So that provides, more flexibility of controlling, defining the tool. I hope you understood how does it work. Uh, but now, the second thing, like the file system, just quick demo. I'll not go into this one, but if you go over here, file system, so you can see that the command line, right? So that's what we need to pick up. So if we'll go with the npx approach, so the command is this one. So basically you just have to copy this block and put it in the server. So here, since I will be running in my Linux WSL, so I have to give you this kind of path. Okay, if you are using the same on Windows, you can give C colon those kind of path, and you can do that. But so basically here, the command, see this entire block I have copied, and I did that. And next again you can call the tool list, and then the same what we have done, right? Chat interface you can connect, and you can ask like can you list the file content of this MCP server. So okay, so in short, don't worry about the much code. Okay, very simple code. Okay, we first import the libraries, and then define the local model, or you can use the actually OpenAI model, and then this is the line of code basically where you are creating an agent and specifying the MCP server. Okay, so this is the simple boilerplate code using which we can configure an OpenAI SDK agent to connect to an MCP server locally. Okay, so yeah, so in the next video we will do the same thing, but I will show you how to use the HTTP protocol. Yeah. I hope this video was useful. I know like it might be very confusing in the beginning, but particularly this OpenAI framework, I have already created separate video where detail I have walked through the code. So please watch that so that you can understand the code, but you get an idea, right? Overall, like how the MCP server you can connect. So thanks for watching. I'll see you in the next video.